All right, now let's move on to our next problem. Our next problem here just asks us, how do we simplify sine of arctan of x? Okay, so our seventh problem here, let me just zoom in a little, zoom in, and our seventh problem here. Okay, our seventh problem here asks us to simplify sine of tan inverse of x. So first, I know some people like to use the notation of the inverse of tan of x, but I don't really like that notation. I like to use the notation of arctan of x, because the inverse of tan of x, some people just confuses it with cotangent, which is the reciprocal of tan x. So like this is kind of a confusing notation. So I prefer just to use arctangent of x. Alright, so we know that this, alright, actually let's put this thing in blue so that you're not confusing it with our steps, because this is kind of like a side note or like some pre-existing things that we already know. So we know sine of inverse tan of x is basically just saying sine of arctangent of x. So important thing, or I guess I should start by saying that there are two main ways to solve this problem. Two main ways to solve this problem. I prefer one of them, and the one that I'm going to show you is probably the easiest or the more intuitive way of the two. Let me just briefly state the two possible ways. The first way is to use a lot of trig identities. So a lot of trig identities. Which specific trig identities you're going to use will depend on the specific question. But to me, it's just kind of like confusing and not as intuitive as like the other way of solving this problem, because you need to memorize all the trig identities and you need to get your head really clear about those trig identities and what they mean, which is just not as easy as the other problem. The second problem is just like drawing the triangles. I think it probably has a fancy name, but I just like to call it drawing the triangles because I don't know, it just sounds more straightforward to me, and this is actually like a really straightforward ways of solving this problem. Alright, so I'm going to solve the problem using the second way or the way that's more straightforward. Okay, so before solving this problem, I just want to give you a note. So like, note. So we know that the arctangent of x is the inverse of the tangent of x. And we also know that sine of x, cos of x, and tangent of x, they take in an angle and they outputs a value. So the inverse of the sine of x, or the inverse of sine, cosine, and tangent, they are the inverse, or they are the opposite, or they like they are like the output of the sine cosine, and tangent of x is the input of arcsine, and arctangent of x. So we also know that sine of x, kind of the input is an angle and the output is a value or a number. Similarly, the tangent of x, the input, or the arctangent, so like arctangent of x, the input is the value that the tangent of x outputs if the x is the same, and the output is the angle. So we know the arctangent here, or arctangent of x, is actually equals to an angle, which means that sine of arctangent of x is actually sine of an angle. So let me just say sine of arctangent of x is equals to sine of an angle of theta here. So yeah, I just kind of want to get this really clear in your head, because some people, they just or I guess a lot of students, they just look at this expression, and this expression just kind of scares them a lot, because they're like, oh, how come like a tangent is instead of a sine, because that doesn't quite make sense. Well, the answer is just because the tangent, or this is not just the tangent of x, but it's the arctangent of x. So it's the inverse of x, and it's what tangent of x outputs. So the tan of -1 of x, let's just me write it down here. The tan of -1 of x, or the arctangent of x, or the inverse tan of x, is an angle. Sometimes teachers or instructors, they purposefully write it this way to confuse you. And yeah, don't be confused, it's just an angle. Alright, now let's move on to our process of drawing a triangle. So you can just draw a random triangle, any way you like. As long as it's a right angle triangle, then it's fine. So yeah, just draw a right angle triangle. And from here, we know that our arctangent of x is equals to an angle. So let's just write an angle here and pretend that the angle is the arctangent. Also, we know that the arctangent of x is an angle, and we know that the tan of this angle is actually we don't know, but we know that we're trying to find the arctan of x. So, and again, we know that the arctan of x is equals to this angle. Write them over here, I'm just rewriting it again. So the tangent of the angle, tangent of the same angle is equals to x. As I've said before, the tangent of an angle is equal to x. X is a value, and the arctangent of x is the inverse of the tangent, or the arctangent function is the inverse of the tangent. So the arctangent function basically eats what the tangent of x outputs and gives what the tangent function input. Okay, so now we know the tangent of the same angle is equals to x. So the tangent of the same angle is equals to x. We also know that tangent is equals to opposite over hypotenuse, and we know that the function x is also equal, it has the same value of x equals x divided by 1, because x is just the same as x over 1, because any number over 1 is that same number. Okay, so we have x is equal to x over 1, which also means that the opposite can be x. So we have opposite equals to x, and hypotenuse is equals to, oh, I'm really sorry, tangent is actually opposite over adjacent. The formula, oopsie, the eraser doesn't quite work. Oh, is that a problem with OneNote again? Maybe I should just switch to another software, because OneNote has so many problems. Okay. Tangent is actually not opposite over hypotenuse. Tangent is opposite over adjacent. So let me just write adjacent over here. Okay, so tangent is opposite over adjacent. So the opposite here would be x, and the adjacent here would be 1, which also means that the opposite of this angle is x, as we talked about over here. So x is over here. And the adjacent of this angle is 1, so 1 is over here. As we noted previously, this angle is a right angle triangle. So based on the Pythagorean theorem, states that a squared plus b squared square root equals c, where a and b are two sides of the triangle, and c is the hypotenuse of the triangle. So here we have a squared as our x squared, b squared as our 1 squared, and we have a squared plus b squared equals to the hypotenuse of the angle. So now we had both our a squared and b squared, and we know our hypotenuse is x squared plus 1, or the square root of x squared plus 1. So now we filled all the information of our triangle. Nice! So what our next step is, we already know that So we wanted, let me just remind you that we wanted to find the sine of the arctan of x, and we also know that arctan of x is theta, so we want to find the sine of theta, and the sine of theta is the same as the sine of this theta over here. So we know from the trig, the basic rules of trig, that sine of x okay. Oh, OneNote is not working. But our sine of x, yes, does it start working again? Perfect, perfect. It changes the color of everything, but I mean, it's working. So let me just change it back to black really quickly. Change the sign to black. And let me just continue with our solution. So we know as the sine of x is equals to opposite over hypotenuse. And let's move our final solution down below so that we kind of have like a more clear view. So we know that sine of x is equals to opposite over hypotenuse. And our triangle over here, the opposite of the angle equals to opposite over hypotenuse. And our angle here, the opposite of our angle is x. So the opposite is x. And the hypotenuse of the angle, the hypotenuse is the square root of x squared plus 1. X squared of x squared plus 1. So sine of theta, okay, let's write sine of theta up here. Okay, so we know that the sine of theta, or in other words, the sine of the arctangent of x is just equals to x over the square root of x squared plus 1, and that's our final answer. Okay, that is kind of a long solution, but I guarantee you that it's easier and more straightforward and makes much more sense compared to using a lot of trig identities. So let's just do a quick recap. So first, we know that the arctangent, or first we know that the arctangent of x, or the inverse tan of x is just the arctangent of x, which is actually an angle. And we know that the sine of, we're just trying to find the sine of an angle that is the arctangent of x. So we just want to find the sine of this angle, which is the arctangent of x. So based on the fact that the arctangent of x can also be expressed as the tangent of the theta, which is x over 1, so we can just fill in the blanks of the triangle with the x over here and the ones over here. Then we would want to find the hypotenuse of the triangle because we're trying to find sine ultimately, and sine is opposite over hypotenuse, so we need the hypotenuse. We use Pythagoras theorem to find the hypotenuse of the triangle, which is just a squared plus b squared equals to c squared. So it should be quite straightforward, a simple calculation. Now we have the hypotenuse of the triangle, and we know that sine is opposite over hypotenuse. So we just find the opposite of this angle, which is x, and we know the hypotenuse of this angle is the square root of x squared plus 1. So we just do opposite over hypotenuse for our sine, which is x over the square root of x plus 1. And this is our final answer right over here. Excellent. Now, this concludes our problem of simplifying the expression sine of arctangent of x. Now, let's look at our sample solution on our left-hand side. They actually used the first way, which is using trig identities. It is quite long, but essentially, or at the end, they arrive at the same answer as us, which is x over the square root of 1 plus x squared. Nice, and these are the 3 trig identities that they used. Nice? Let's look at, so they have, or I guess we can briefly step through the answer. Arctangent of x is theta, right? X equals tan theta, perfect. Sine of theta equals tan theta over secant theta. because tan of x equals sin x over cos x, and secant theta is 1 over cos x. Cool. And they just interchange the x here with the tan up above. Alrighty, so let's just say convex solution. Good job. Good job. Okay, now let's move on to our next problem over here.